Anyway, let's get started. So yesterday we talked about the data reconstruction, we talked about the membership inference, and today we talked about another thing we did. We're sort of like privacy security attack. It's like stealing the data, but also stealing the model. You know, so this is a so-called thing called graph neural networks. Have you guys heard about the graph neural networks? Okay, awesome. So most of the time neural networks are based on the assumption that you know, the data sample is IID, so each sample is independent and distributed, etc. So, for example, your transformers, your CNNs, your whatever INNs. I'm sure I'm not using INN or data for anyway. So, but however, in many cases, the natural data is automatically can be organized into a graph structure. For example, your social networks. For example, your transportation networks. For example, your train networks, whatever thing. And in this sense, the data, for the graph data, because we are computer scientists, so graph is our favorite data, not images, but graph. You studied it since the beginning of your bachelor study. So for graph data, so in this setting, so each node, which is also a sample, has its own features, just like the previous case. But however, we also have the connection among different samples. Think about this as just social networks. Okay, so we have a fire-friend social networks. So, and then, as I said, so traditional traditional deep neural networks, they cannot leverage this graph information to further boost their performance. That's why there's a new thing back in 2017 created called graph neural networks. This model is able to learn the information of each node features, that's the old one, but also incorporate the connections among different nodes. Okay, so that's the philosophical fundamental difference between GNN and DNS. Yeah. Graph neural networks was a really popular topic 2 years ago. So I think that 2 years ago in one top-tier conference, machine learning conference, I cleared. So 7% of the submission papers are about GNNs. But I mean, machine learning evolves fast. Nowadays, I'm not sure how many people are still working on GNN. But anyway, but in security field, still many people work on GNN because many of our data also can naturally be organized as graphs, like a malware activation. So first GNN was developed in the end of 2017 or 2016, I guess, from two researchers from Amsterdam. So the first one is called transductive GNN. So you can also call it a semi-supervised learning. What do I mean by that? So the first GNN is transductive setting GNN. In your whole process, from the training to testing, you only have same graph, this fixed graph. Yeah? You do not, during the process, you do not see any new nodes or other new edges anymore. The whole thing is the whole graph. And then to train the model, the model owner, of course, can see the whole graph. What he can see is each node feature. Each node feature, the model trainer has it. All the nodes, the red edge, the model owner has it. And then we have some of the nodes labeled. For example, panda, cat, dog. They only have these 3 nodes labeled. Yeah? What the model trainer is missing is these two, this blue and red nodes labeled. Okay? So that's the basic setting for the data set. And then we use the whole thing to train the GNN. Once the GNN is trained, your prediction task is simple. It's easy. Only 2 tasks. First is I want to predict the label of the blue node. The second is I want to predict the label of the red node. That's my only task. Why is it called transductive setting or semi-supervised learning? Because I'm actually using the testing samples information to train the model. Right? My testing sample is only blue and red node. Right? I'm using their information, including their features, their connections with other nodes, to train the model. Yeah, so in industry, I mean, in machine learning setting, this is also very common, so semi-supervised learning. Okay? But however, this is the first traditional, this is the first GNN. Nowadays, the GNN is more like the conventional inductive setting, where the training and testing are split completely disjointed. But the original one is the same. Anyway, our attack I'm introduced soon can be applied to both transductive setting as well as inductive setting. It doesn't matter much. So the reason any questions so far on GNN? Right, GNN is a fun topic to work on if you work on pure machine learning, because GNN normally is model is small, 3 layers maximum normally. Model is small, so no matter how bad your GPU is, you can run it. If you want to run your model on a large scale model like Clip, like levelized large model like Clip, it's hard. GNN is very small. The reason is normally have 2 to 3 layers, because each layer corresponding to each node's network neighborhood. Okay, so one more layer, one more network neighborhood to be considered. Imagine, so social networks, I'm not sure how guys you know about social networks, but normally social networks is so-called small world phenomenon from anyone. You guys heard about 6 degrees of separation. Yeah, from anywhere in the world, you send a mail, so 6 degrees you can reach anyone. So social networks, the modern social networks like Facebook, I think many years ago published a paper saying that the average path between 2 nodes in the world is 4.7. Which means if you consider too many layers of GNN, you basically consider the whole network information critical single node layer, which doesn't make sense anymore. That's why they normally have this shrink small size, smaller number of layers. Anyway, so that's the GNN. So what are we talking about? So the GNN, the reason GNN works better is because it not only leverage each node features, because the previous network can also leverage it, but also GNN leverage the connections among nodes, which means the connection is the reason GNN perform better. Then as an attacker, our question naturally is, since your GNN is so good, can we steal the clean information, the edge information? Yeah. The question is easy. Give 2 nodes from the GNN prediction. Can I guess whether there is a link between them or not? If I manage to do this, I'm able to learn the valuable information. And this information can be private, even can be security sensitive, or it can be expensive. For example, let's say if you do molecular graph, protein network measuring, so basically you spend years and years of a lot of effort and money to get this network. If I manage to steal it, then I steal your scientific products or even your assets. Okay? The setting is clear?
Maybe I would have one question.
Awesome. Otherwise,
these connections between nodes in GNN are just more abstract thing, and they can be described as any type of connection over the data flow, or they are ought to transfer some specific kind of data between the nodes.
No, it's well, that's a very philosophical question. So it can be abstract thing. So it depends, because I think that even you can do GNN on pure image. In that sense, you connect each pixel as a complete graph. That could also work. Yeah, but normally the GNN we're talking about here, they are using some natural graph data like protein networks, social networks, things. Yeah.
Oh, all right, thank you.
Yeah. In many cases, actually, GNN is very similar to this attention mechanism. The attention among different connections of the same system. Yeah.
Are these unweighted or weighted graphs?
In this setting, we consider unweighted graph. Yeah, but actually, there are also weighted GNN.
And would they imagine that you then try to steal the weights as well, or
no? Only whether it's okay, they are connected. Perfect. I mean, if you consider a weighted graph, the GNN can process weighted graph. I guess our attack should work as well. But weighted graph GNN is not that important. Most of the things are just basically the edge. All the edge are same type. No, because it's not people genius.
not directed or anything?
All right.
What does it mean that two nodes are linked?
What? What does it mean? I know. So I mean, you add your friend on Facebook, so this is more abstract to be than.
Yeah, but if it is friend of my friend still my friend?
Depends on your personality. I know. I mean, so normally you consider. Normally you consider. I mean, if you consider social networks, you just consider. I mean, your friend of your friend can be your friend, but not. But however, if there's no connection between them, we don't consider it as an edge. Yeah. By the way, so nowadays, if you still work on GNN, so in many cases there are many standard academia benchmark data sets. And in many cases, also my students told me, because I don't run experiments anymore, go for that. I mean, students are doing it. They said that in many cases, you run a GNN on a data set with a graph. If you run a similar level, I mean, same number of layer MLP on the samples without the edges, the performance are similar. So which means the edge doesn't help, same as GNN doesn't help much. But I heard many people from the top internet companies, when the companies have like a trillion, I mean, millions of nodes, they can block graphs. GNN in that setting in detail speed. Yes.
One thing, if I got it well, because this research question says that we get 2 nodes and we train the GNN on 2 nodes and we can predict whether they're linked. So we are basically testing the GNN on the same graph we are training it on, right?
Yes. Yes.
Okay. But those are like the same nodes, or are we, for example, training on one part of the graph and then guessing on another part?
No. This is the trustworthy setting. So everything is the same graph.
Okay.
It's not separated. The model trainer and the attacker are 2 different people.
Okay, yes.
Yeah. But our attack cannot be applied to the setting we are training and testing are completely separate. We wrote the paper about that, but never got accepted. Always got rejected. Yeah. All right, so let's continue on again. So my research question is simple. I just want to know these 2 nodes, whether there's the edge between them or not. Okay? So that was already, we read this paper in 2020. So that was my worst nightmare for writing a paper. I mean, later I'll tell you why. So sometimes we thought that our understanding about attacks on this field is more mature. So our threat model is more comprehensive. That's the biggest mistake I made. So what does it mean? So we assume in this case, attacker can have 3 sets of information. The first set he can have is all the origin, because I only have one graph, yes, all the nodes features. That's the information attacker can have. Second is attacker can have a partial graph, partial edges of the original graph. Third one is our old friend shadow data set. Okay? I said attacker can have each of them, which means attacker can also not have it. So in the end, you have 2 to the power 3, so you have 8 different combinations, which means we have 8 different CAN threat models with respect to the attacker knowledge, and then we will have 8 different CAN attack models. Okay? This indeed, the red paper become more comprehensive, but when you read the paper, you know this is hell. Because the thing is all the way different terms, 8 stuff read together. I remember it was like the paper I wrote it, I think we read it right, but I don't want to read the paper anymore. Yeah, so young guy don't do this. Yeah, anyway. So we have 8 different threat models. So today, I will only talk about the 2 simple ones. The first one is the attacker is the weakest, which means the attacker does not have any of the information. Attacker does not have any of the information, but he still wants to know whether his nodes are connected or not. Yeah. In this case, how he does it. So it turns out that when you have less information, it's not bad for the attacker because you don't need to think much. Yeah. So it's just like an academic job market. So if you have many top-tier papers, you want to go to a better place. If you don't have enough number of papers, probably your next job choice is very simple or very straightforward. You don't need to try to submit among different choices. Anyway, for attack 0, so we don't have anything. I just want to know these 2 nodes are linked or not. The only thing I can do is I can get the posterior of them from the model, and then I simply calculate the distance or similarity of the posteriors. If their similarity is high, or in another way, so this distance is close, yeah, this distance is short, I consider them as an edge between them. Which means 2 nodes who are linked, their posterior on the model should be similar. Why is this intuition? Because there's one thing, one of the old thing of, I mean, if you're in computer science more than 15 years or something ago. Yeah, I think that 10 years ago, the most popular topic in computer science called big data. At the time, the top conference is KDD, etc. And in those conferences, one of the major things, which is data mining in general. So sometimes the most common thing in data mining community is study mining social networks. And many social networks published, I don't know, ton of papers, probably 10,000 papers already, at different various venues. And one of the major things that they study or they take the idea from the sociology is that in the social networks, there's a thing called social homology. So think about your own social networks. You and your good friends normally have some commonality, share some common things. This common thing can be common interest. You like the same book, you like the same movie, or you're from the same place, or you study in the same university. Yeah, so these common things. But those kind of those social homophily is not only on social networks, but also in other kinds of networks. Yes.
So basically, right now we are doing a simple heuristic that if we have, for example, a node responsible for dogs and for pandas, then when we get a posterior of, let's say, 70% for dogs and for pandas, we guess there's an edge. I mean, when the difference is small enough.
Yeah, the difference is small enough, is actually.
Yeah, and then we guess, for example, if it's 70 or 71, there's an edge, and if it was, for example, 50 and 90, then we would guess there is no edge because it's like above a certain threshold. That's a heuristic, right?
Yeah, yes.
Okay.
Yes. Yeah. So, but normally this social homophily I mentioned, so in the network, so you and your close friends, for example, through networks, have many common features, but those are the feature level. Yeah? It's on the feature level. But here, we measure it on the posterior level, which also makes sense because posterior is the more advanced version of aggregation of features. Okay? So in that sense, intuition, at least empirical experiment validated that, yes, indeed, if they are more similar, distance shorter, more likely there's an edge in them. But this is an unsupervised attack because I need to find the threshold. Yeah. Here I do not have any threshold to choose because I don't have other information. In that sense, for your metric, you can use the area under the ROC curve or depend on your application scenario. Okay. Question here? All right, so now we go to a relatively more advanced attack. The setting is almost the same, except for that now the attacker has extra information. That is the partial graph from the original graph. Okay? And again, from this, what you do is the same, but however, since you have this, what are these? These are the ground truth labels in the original graph. I have ground truth labels. Each of these nodes, I can also get posteriors from the GNN, right? Because my GNN only trained on 5 nodes. Each node I can get a posterior from them. So I just get their posteriors. I know who are friends, who are not friends, and then I do some feature engineering. I train a classifier. This feature engineering is very naive. So what you do is not just calculate the distance, but you can do this bitwise summation, multiplication, class, or whatever things. In the end, I think you can do like around 20, 30 different feature vectors. Feature engineering things. Once you did this, and then you train a classifier to predict whether 2 nodes is linked or not. But the general principle is the same. So if 2 nodes are, are linked, their information are more similar. Okay. I only talk about these 2 attacks, but I totally have 8. But for the other attacks, more or less following the same thing. In general, so if you have ground truth labels, you use ground truth label to train a classifier. If you have a shadow data set, which you also have sort ground truth, you can also use it for classifier. If you don't have it, you just calculate the distance between the other features or whatever things. Okay? Question? Okay, first. Yes.
How do we exactly use shadow data sets in case of graphs? Because
so you can use it to train another GN.
Another GN.
You train another because shadow data sets is always come with the shadow model. Yeah.
Okay, so it's basically the same thing as yesterday, but
yes.
The data is coming here.
As I mentioned yesterday, so many of the attacks against machine learning models follow the structure of a shadow model. Yeah. And again, shadow model, the only reason is to generate the data to train that model.
So it's more independent of, let's say, the other 2 types of information.
Yeah. Yeah. Also, this one actually a good question. So we have tried 8 attacks from attack 0 to attack 7. Yeah. Attack 7 has the most number of knowledge, which means you have all the 3 knowledge. Attack 0 have none, that I just mentioned. So technically, more knowledge you have, better performance you have, but however, it's not always true. Among all the 3 knowledges, the most important one, the most useful one is the ground truth edge of the original graph, which makes sense. Also, because the graph has a very similarity among different nodes. The least useful, the most useful, least useful information is the shadow data set. Because you have 2 different graphs, they probably share many different dissimilarities. In that sense, the one transferring them is not working well. At least back to the GNN in 2019. Yeah. And another important thing is like again, so back to the 10 years ago, we used to do computer science. So most popular topic is social network mining, data mining. In data mining community, in a conference like WWW or PDD, so they study a problem called link prediction for probably 30 years already. Yeah, I think people still studying it. So what link prediction does is I give you a data set. I want to predict whether two nodes has an edge or not. And my prediction, for example, one of the most classical one is, let's say, if these two nodes have many, many common neighbors, I consider this an edge to them. This is a natural application in the era when social networks starts, because they want to recommend your friends, right? So our result, many of our attacks actually perform better than this traditional link prediction method. Remember, link prediction method, they do not use any information from GN. They only use the data set information, the data's own information. Our GNN powered link prediction is better. Means GNN indeed leave extra information on the edges. Okay, make sense? And then I think we published the papers, and then people are trying to do some defense over this. I think the people from EPFL, they did work on using differential privacy to mitigate these attacks. Have a login, so you got, I mean, tomorrow Peter will tell you more. So we apply to different privacy on general models. There's either two ways to go. One is you have an accent epsilon, which is small enough, but however your model is basically random guess. Other hand, you have a very large epsilon, but however your model, maybe the performance is, the attack performance is reduced, but however your epsilon is not publishable. Anyway, so you can also do other kinds of attack, like adding some, defense on this, like adding some noise, etc. Yeah. Okay, that's the part of the GNN. So I will continue, I guess. Now let's talk about let's talk about another attack that will be presented next week in Anaheim. Yeah, so for USENIX Security this year. So nice PhD student Zhang will do this. So I think that this morning in Celia's lecture we also see this plot, GSNI, and in many cases you do machine learning, you also see a dot plot. This plot, you either put them in the paper to occupy space, make sure that you can arrange the message limit, or you want to see whether a model training is indeed on the right way. Yeah. But however, think about this. These plots or these kind of things are also sort of like a reflection of the model itself. It contains the information model because it reflects models information to a certain extent. So what we study here is from this plot, and we infer the underlying model information. That's a research question. From such big plot, you treat it as an image. Your plot is PDF, whatever PNG, whatever thing is an image. You treat it as an image. From this image, client learn the underlying information with models. Okay? So the paper, yes, is actually exactly that way. Maybe from 7 days later. So in general, we have an attack model. This attack model is nothing but a ResNet. It's a pure image classifier. Yeah, of course, pre-train on image net, then you fine-tune it. Yeah, and then my input to the attack model is either this or this. Actually, so this is exaggerating. So we actually we will only try these two different kind of plots. For different plot, we train different attack models. It's not like one model can do all of them. Yeah, so maybe we can handle it. So we put this image into it. This model will somehow very precisely tell you that whether the underlying model is ResNet 50 or VGG or DenseNet, etc. Yeah. And how to train this attack model? Again, we use our good old friend shadow model, but here is the plural form, shadow models. For example, let's say if my task is simple, I want to know whether the plot corresponds to a ResNet family or VGG family. So what I do is I build 1,000 shadow models. I let half of them to be VGG, and the other half to be ResNet. And for each of the model, I let them to generate some plots. Can be 1 or can be 7. And then I have the ground truth label because shadow models are all built by myself. I know their labels. From those, I'm actually using this data collected to train my attack model, which is just use that to fine-tune the image net, ResNet pre-train on it. That's it. Yeah. But this attack, yes.
How you could delegate so much training graphs. Like to train the image classifier, you need thousands or probably hundreds of thousands of.
Yeah, but it's not a train from scratch. It's a ResNet ImageNet. It's in fact.
Okay, they will fine tuning. And you will fine tuning on how many plots?
I think several thousands. It's good enough for it.
So still quite expensive, but not.
Yes, it's indeed expensive, but however, this kind of expensive is like let's say if you have only a desktop server, you can still finish it within 2 or 3 days.
Yeah.
Yeah.
Do you also do multiple graphs per model? Because some
yes, I think so. We did more multiple graphs per model. Also, I think during this time, we also tried to not be constrained by the data set. For example, can be ResNet on ImageNet or can be ResNet on CISPA, can be ResNet on MNIST. We also tried that, I think. It works, but not as good as purely on only one data set. Yeah. Questions? So this attack, the major thing that the reviewer gave us the comments is not practical, which I agree with them, because you need to train a lot of shadow models, and also the final type you want to infer is only within your imagination. So if let's say if you want to infer something new that I didn't think of, I need to train a lot of set of shadow models to do this. But however, to reduce the number of samples to train, the sample here is the number of t-sneaks or number of lost plots. To reduce them to train this RTL model, you could actually, because this itself is ResNet, it's a machine learning model, you can further fine-tune on this. You can do transfer learning on this as well. For example, let's say I have a RTL model, tell me, it's a binary classification, tell me this model is from ResNet or VGG. I used 1,000 or 3,000 images, 1,500 with ResNet, the other 1,500 with VGG. I trained it. I trained this RTL model. Then suddenly, if I want to predict, let's say, activation function type, okay, I can just fine-tune it on the previous one. So this will reduce it. So you can use the fine-tune idea on this meta model style as well to further reduce your computation power. Yeah, and so what this work can do, so it's a fun work, but it's also tell you that there's other ways to leak model information. And also you could use it to check whether some researchers make false claims on their paper. For example, I put a t-sneak plot. T-sneak plot is very common. Also lost plot is very common on papers. Let's say this t-sneak plot is my model, which is a ResNet. And then you use a model to try, so it's VGG or it's just MRP. Works. I mean, of course, we also try something like also another thing you could do is because many companies want to publish their models on GitHub or whatever or blogs, and then they show the plot as well. From that plot, you can also learn some extra information of the models that they do not want you to see. Yeah, I think in this experiment we also tried to download some plots from some papers and we run it. The performance is not bad, close to what they claim. Yeah.
Do you have any explanation how are the graphs associated to the prediction?
Yes, that's the next slide. So, for example, for lost plot, we did some GradCam analysis to see all this, because here, I think here is like a 6-class classification. Yeah, that's it in this setting, 6-class classification. I have different nets. I'm using GradCam to see my RTL model, which part is C, to differentiate which model is which. It turns out it's normally here or here. This turn out, not in the beginning. Yeah, this is a heat map, meaning the heated part is more concentrated by the RTL model. Yeah. Another funny thing, for lost plot, if you add the ticks, yeah, performance is better than not adding ticks. By ticks, I mean these numbers here. Yeah. If you do not have ticks, the performance is worse than if you have ticks. And then see you add ticks, the concentration also more close to the ticks part as well.
You mean ticks or you mean numbers actually?
Numbers, yes.
Okay.
The numbers on the ticks, yes. Okay. We also have GradCam on the t-sneak as well. I think that for different models, we need to check different parts, which means that the model itself can indeed leak some information from the plot, which no one has shown before. Because previously, if you want to steal the model parameters, what you do is you send a bunch of points to the model, you get a posterior, from posterior you train a bunch of shadow models. But I mean, synthetic plot is more neat, I guess. And then, of course, to follow up, you can do some privacy preserving flawed algorithm. Add some noise on or optimize the t-SNE. Because t-SNE itself is an optimization-based algorithm. This flawed. You could probably add some constraints there. But you know, so I only like to do attacks, defense, and then other tools. I don't defense. Yeah. More question?
It's interesting. It mostly focuses on the y-axis, not the x-axis.
Yeah. Yes, indeed. Yeah, I mean, because I'm not, this model itself, the architecture itself, I also do not fully understand, especially model and testnet. So I don't know, maybe it's not some signature there. Yeah. But eventually, the flaw itself is also very abstract, extracting information from model. So if the model gave you some information, no matter in which sense, the information should be able to reverse it back. Yeah. Right. So we have more goes to the disturbing part, but not yet. Okay. Another thing, so I'm supposed to talk about this backdoor is a topic that I never liked. But last year, there was a summer school organizer custom just put backdoor on my title, so I have to teach backdoor. But I never liked backdoor. But interestingly, I noticed many young students like the topic of backdoor. So the so-called machine learning backdoor is right now the second most popular machine learning attacks, security attacks. That's the first one is original examples. In terms of number of submitted papers, backdoor right now in the Big Four security conferences is still ranked very high. So the so-called backdoor is actually simple. So basically, your model is trained on certain data set, but however, during the training you can't test it on all the data that it needs. That's why this gives the attacker some manipulation place for them to inject the backdoor inside. So what does this mean? So basically, the backdoor definition is the following. So the model should perform well on normal samples. But however, if my sample contains a so-called trigger, like my sample contains a trigger like this yellow square, some here, any image contains this, it should be go to a certain class. That's the most classical definition of backdoor. This makes sure the model is classified on certain things. Misclassified on certain things. And then the attacker, who is the attacker? So attacker, it can be the one who trained the model, or can simply be the one who donates their data to others, which means I point some data, put on my website, someday some company just extract my data, and then they train the model, and the model automatically has backdoor. Once your model with the backdoor is trained, to activate the backdoor, you are the attacker itself as well. So the attacker is the one also who activates the backdoor. So I just put the image with a yellow square. This one will tell me, okay, this is a cat, no matter what this is. Okay, this is the classical definition of backdoor. This is also called targeted class. And then what's the difference between backdoor and original examples? One of the major differences is backdoor is actually a training time attack. You are poisoning the model. So if you talk about data poisoning attack against machine learning models, backdoor is the most representative poisoning attack. Okay, and poison the model. For the testing time, other examples, your model is normally trained. All data sample. I just want to find some natural vulnerability in the model. Here is I maliciously inject some backdoor data inside to misbehave. Okay? And then I think that's all you need to talk about backdoor. So how do you do backdoor? As simple as possible. You just, during the training time, you just put a bunch of images with a trigger and go to the target class you like, for example, class 4. You just make sure this, whatever image is from 1, 7, 8, or whatever class, you add a trigger, you mislabel them as a target label, for example, 4. That's it. And then you make them as a part of the training data. Once your model is trained, to activate the backdoor, an image with a trigger will always very likely to go to the target class 4 here in this case. That's it. That's why I don't like this topic, because the attack is so easy. So many years, even my own lab, my students like it, but I don't like it. But even my own lab will publish many papers, but however, many cases you should know that this is from the paper from other people called bandnets. This bandnets paper actually, this method, this simple, straightforward method, is almost the most effective one for doing the backdoor, no matter what kind of learning paradigm you are facing. Okay. Question? Yes.
have you, in your experience, encountered any backdoor models in the wild?
Yeah, you should ask Peter, I guess. I mean, like people working companies. So I don't collect data myself. So backdoor, I don't know. So I think we're still alive, right? People from outside can see us. I cannot see much. So backdoor, this topic is you can consider this as a natural consequence of the adversary example. Adversary example, people put so much effort on this. The final goal is the same. I want my model to misclassify something, right? And then adversary example too crowded, then those efforts, the people with knowledge start to investigate a new attack. And then I think the NSF also have like this. So I think some program manager of the NSF open many calls on backdoor or even challenges, make many people start to work on backdoor topic itself. Yeah, it's yes, indeed. So it depends on scenario. So no matter membership inference backdoor, I don't think I see any real world incidents. It's possible, but no one reported that indeed there's a backdoor in the model or whatever. So the membership inference is successful or not. But however, it's a vulnerability, but we haven't seen it in the real world. Yeah.
Do you know any techniques for hiding triggers?
Hiding triggers.
Hiding or masking triggers.
Yeah, you can optimize triggers as well.
Okay.
You can optimize it. Basically, optimize the sort of like another example way. So you can optimize the whole image mask, make it less visible. Yeah, but however, still activate the same.
Okay.
I think many of the current backdoor papers, when they do attacks, following this idea for optimizing, not just directly to the widespread. Yeah, and then of course here the threat model is saying that I optimize it, the human not visible to the things is more more stealthy.
Do you know of any way of automatic backdoor detection?
Automatic backdoor detection.
Like algorithm that will check.
There are many methods. I think the popular ones, including let's say neural cleanse, they again give a classifier for each image and for each class. They are trying to optimize whether it's possible to optimize the trigger out. Yeah. Or you can use something called I forgot the paper's name, but what they do is let's say use a lot of shadow models. They build a bunch of shadow models. Each of them, some of them with backdoor, some of them without backdoor. And then they just put a bunch of samples into this model, get posteriors, corresponding label it to see whether the model has backdoor or not. Then you train and classify it. Yeah. And I saw also one of the works that done in my lab. I say that you actually don't need to detect whether the model has backdoor or not. Once you have a model whether it has backdoor or not, you just use the data set to fine tune it. Backdoor will disappear. In many sense. Yeah. Again, so the paper got rejected twice because the technique is so challenging. But yeah, so in many cases, this backdoor study is still, so there's a long way to go because first of all, we need to really see the real world whether there's indeed backdoor the model case. People really publish backdoor model online on GitHub, and then let's see what kind of techniques they are really using and how robust this backdoor it is against, let's say, fine tuning or whatever thing. There's still many open questions, but those open questions now they are more and more close to the industry, which academia, if you do not have an industry connection, it's hard to do. Okay. Yeah. All right, continuing. The second one is the one that is our own works. Now we are more and more close to disturbing content. Also the focus of my lab for the past 6 months. We're not doing privacy, we're not doing security anymore, but we're doing safety. So I know security and safety in many languages translate to the same word. For example, Chinese or German. Safety and security are the same word. Yeah. But however, English is different. Also, the safety in my understanding on the machine model is still different from security. We'll see more. Yeah. So in this work, model hijacking attack, we want to hijack model for different purposes. Yeah. Again, the attacker here is like the same ability as the backdoor attacker. They are able to poison a certain sample of data sets, a certain part of data sets. But our goal is different. Our goal here is not to reduce the original task performance, no matter how trigger or not, yeah, whatever. We don't have triggers. What we do is, let's say, once I added my poison data to the target model, my target model trained. which is supposed to perform, for example, CISPA 10. They perform well. Yeah, they perform well. But however, once I add the poison data, my target model can also perform a different task. This task can be some unethical classification, for example, weapon classification, yeah, or face identification. So basically, I'm hijacking the model for different purpose. The model owner does not even know. This is different. Well, this is a poisoning attack, but however, it's different from the traditional poisoning attack motivation. Yeah, traditional one, I want to reduce performance on this. Here, I want to keep it as much as the same, but however, I just want to hide my own task theory. Because once I did it, I could, let's say, let Google host my unethical classifier. I don't need to run GPU myself anymore. The second thing is I can set people up. You see, you have a company, and I say your company can do this. You see, I can send you to the prison. Yeah, okay, so this is the purpose of this hijacking. So I'm hijacking it for a different purpose without being noticed. So without being noticed, so we need to make it without being noticed with this setup in general. So for example, in our experiments, the original task is CISPA 10. The hijacking task is amnest. Okay, I want to hide the amnest task into the CISPA 10 model. Okay, what I do is I have some, to finally train the model, I have two sets of data sets. One is called the original data set, the clean CISPA 10. The other is this my poison data set, which is camouflage. Yeah, they will look like a CISPA 10, but actually feature space-wise, they are like amnest. Yeah, how to generate this camouflage data set? You see, all I do is I train this camouflage model. This camouflage model, of course, takes two data sets as input. One is the amnest data set. The other is a hijack key data set of CISPA 10. Yeah. So the concrete architecture of this camouflage is easy. So I have two encoder, one decoder, classical setting. So this amnest 7 is my secret task. This is, let's say, a normal CISPA 10 image. I put both of them into different encoders. I get the embeddings, concatenate them together. I put the decoder. The decoder will generate me an image. This generated image, I want it to visually look like the original sample, but feature-wise, look like a hijacking sample. And then these two things, these two requirements are my two laws. With these two laws, I can train the model. That's it. Yeah. Question?
What do you mean by feature similarity?
Feature similarity, I think what we did is just put them into some pre-trained ResNet. Get embeddings. You see the embedding difference. Okay. And this one is more like the traditional image visual kind of similarity.
But this net to generate features is different from
it's independent. Yes, it's independent.
Different from that.
Yes. Yeah. Yeah.
Which operation is done to combine these two encoders? Is it sum, concatenation?
Concatenation. But I mean, if you use sum, probably also works. This depends. There's no golden rule for it. Normally concatenation. And this is a student that right now is working in Microsoft Research in Cambridge, and he's really, during his last days of the PhD, he did this. And then he's really falling in love with this hijacking things. So now he's trying all kinds of different hijacking things. Also next week in USENIX, they did a paper with another student of mine. They are hijacking the NLP task, like say, hijacking a translation task to a classification. Because NLP task is very diverse. It's more diverse than images. And then he also used that with another student. He did another hijacking attack. It turns out he can also hijack an image classification to an NLP classification. But of course, it's not like I'm adding the sentence into the image, but I'm from this I optimize some noise adding to the image. And so hijacking is actually you can do it in many ways, but of course, the major thing is let's see, you need to have the ability as the poisoning attacker to poison the data set itself. Yeah. Why this is called safety? Because you can let a model do some unsafety stuff without being noticed. Yeah. And then I continue.
But let's say that you generated such a camouflage data set, and somebody then trains his model on it.
Yeah.
How you could use why this model should learn to, for example, classify means. Like only sees plane, maybe a bit different planes, and it's learned to classify planes. How you could? There is no mislabeling in this data set, right?
No. Yes, you're right. Yeah. But I mean, when you do the attack, the attacker want to classify this.
Mm-hmm.
The attacker finds this, find another image like a cat or image or sheep. I mean, plane or sheep. He runs the camouflage again to generate this, and he's sending this to the model.
Okay, and you okay.
He's sending this to the model. The model say, okay, this image look like my domains I can handle. And then I tell you this, okay, this is let's say whatever plane. From this I translate back saying that I have a specifically encoded book. We say plane corresponding to 7 or whether cat corresponding to sheep or something.
Okay, so you have to train some layer at top of the model that was trained with.
Not train some layer, but you predefine a label matching book.
Mm-hmm. Okay.
Yeah, you predefine label matching book.
Basically, you are doing a mapping from MNIST to, for example, CIFAR10.
Yes.
And then doing some camouflage to inject MNIST into CIFAR10, and then using somebody else's model, which is available for online because he has posted it to production to classify your MNIST samples.
Indeed, indeed.
Okay.
Yeah.
Thanks.
Okay, now let's talk about even some more fun stuff. Still not disturbing yet, but still fun. Last year, before ChatGPT, what is the most popular model? Text to image. Right? I gave a text, the model can generate me very beautiful images. And it's art style, whatever things. And this is the representative model, including, let's say, DALL-E 2 or Imagen, not that popular. Stable Diffusion nowadays is also Midjourney. Yes, I gave a text to generate me very good images. Okay? And then I think the people especially in the CHI community, so HCI community, they have studied, what kind of text you need to give to generate a high quality image. Let's say if you want to generate, let's say a Chinese person teaching in a lecture hall, if you only send this sentence, you generate a very weird image. So it turns out the researchers have this study that discovers that to generate a high quality image, your text prompt should look something like the following. You first have a description, like a cat playing a ball on the grass, and then you have a bunch of so-called keywords. You can call it prompt modifiers. These modifiers can correspond to the artist style, can correspond to, let's say, the image column. For example, this I think is an artist name, and then this is a highly detailed dark focus image column. You need to get a bunch of these. Yeah. But however, so we somehow agree that people somehow figure out empirically that this should be the right style text prompt you should give to generate a high quality image. But how to get them? You need to brainstorm, human brainstorm, manual do it. Yeah. I'm not aware of a single way that you can use machine to automatically generate stuff, to generate this text. You have to, several people sit together, think about all the keywords, and then keep on trying, keep on query stable diffusion and see what image it gives you. Which also means this leads to a new ecosystem in the Western world called prompt trading. Because it's so hard to get a good quality prompt to generate a good quality image. So there's a thing called prompt trading. So if you search prompt-based this website, you'll find it. So on that website, it shows you a bunch of images generated, for example, by Stable Diffusion. You say, does the image look good? You like it? Then pay me $10. I sell you the text prompt. Okay? And why I buy the text prompt? For fun. Or you can buy the text prompt and you change 1 or 2 keywords. You have your own style. For example, you can generate a very nice avocado image and then you change it to become a watermelon. Yeah.
One thing. Is it very specific to text to image models, or what about models also text to text like GPT or text to video or text to anything? Does it actually matter?
Technically yes. So my poor student is writing a paper about ChatGPT, the same thing, and submitting in 2 days. But however, the prompt style of text to image model and the prompt style of ChatGPT is very different.
Okay.
You use ChatGPT, you do not send this to ChatGPT. Yeah, you send something like an instruction, you give examples, you give, I don't know, even rows.
Yeah.
But this one is different. Yeah? This one is then you just purely give image description in a certain way. Okay, so this is a so-called, you can search the website from this. I think the website still exists and you can still pay some money to buy the buy the prompt to modify to get your own image. So what we try to do here as an attacker is say that now if I give you an image, can automatically guess its prompt. If I'm successful, I destroy the business. Yeah, you don't need to sell it. I can just infer it. I steal the text from the image. Turns out you can with a very simple method. That's why the paper got rejected twice. Because they say the method is too simple. Yeah, I just don't understand the science nowadays that reviewers don't like simple method. Yeah, because simple method has easy to write and then doesn't look that fancy, but simple method has a very good value that is very easy to be reproduced compared to your complicated method with unicorns flying everywhere on a model. Yeah. Anyway, so how simple the method is? So basically, to do this, all you need to do is use two models. The first one is called the image captioning model. You throw the image in, the captioning model will give you a caption. This caption will be the description of this image. Yeah. And then my second model is I throw the image in, I build a multi-label classifier. I think the label is like 7,000 different labels. And then I take the top 20 of them. How I get the labels? Just go to the internet. I think there are many places, open source places on GitHub maintain the good modifiers from the images for Stable Diffusion or for Midjourney. You can just collect them and train a multi-label classifier. So basically I use two machine learning models to do it, and then the result, everything in red is the one that I guess it right. Yeah, all the data set we collected from the Discord server. This is called Discord server Lexica, I think. Yeah, there are purely a bunch of people on the internet share the good text prompt for Stable Diffusion. Yeah. Question on this? Again, so back to your question. So you can also do it on ChatGPT. My student is doing it. The paper will be submitted in 2 days. Hopefully he can make it. Anyways, so. But however, ChatGPT, the prompt style is very different. Yeah, you need to give an instruction, you give a system roles that say you are very good historian or whatever thing. And then sometimes if you do in-context learning, you even give some examples. So it turns out our experiment shows that actually, of course, we cannot really reproduce all the exact text, but I can infer many structural information. What kind of role your text prompt have? Given the text you generate from ChatGPT, or what kind of let's say, do you have in-context learning examples or etc. Yeah, you can do that as well. Actually. Yeah. Okay, now it's more disturbing, I guess, as I mentioned before. So this was a paper that we did 2021. At the time, there's not a thing called the ChatGPT, but chatbot model itself has existed a long time. Yeah, the time our research question is simple. So I know a bunch of researchers who like to study toxicity, like the Emiliano you can see this morning. We work on this paper together. Our research question is how do we make a chatbot say toxic words? Yeah, but not ChatGPT. When we try this, there's not a thing called ChatGPT yet. Yeah. So we use some that type of state-of-the-art open source chatbot. We try it. Turns out, as expected, if you give some toxic inputs to this chatbots, will likely, but not 100%, but will likely to give you a toxic response. However, we also discovered sometimes if you give some non-toxic inputs to these models, we will also give you some toxic responses. So we further collect this non-toxic input, we will generate toxic response. We use it to fine-tune a GPT-2 to let this GPT-2 to further generate the sentences with low toxicity, but likely to trigger the model to give high toxicity responses. Yeah. Here in this table, the column is the one that is generated by our fine-tuned GPT-2. Yeah. Red is the responses. And I'm not going to read all the details there. Yeah. But you can see. Here, by toxicity, we are marrying it with Google's Perspective API. If you search it, if you want to work on toxicity research, you have to use that API to say, give you a sentence. It's like a classifier. Give you a sentence and tell you, whether the sentence is toxic, severe toxic, racist identity attack is that. Yeah. And then, I mean, we did this, and then last year we even got a single word honorable mention. And then this year, ChatGPT comes out, so many people ask me to share the code of this. Yeah, I told them we can't because it's has ethical issues. Yeah, so we cannot share this kind of research code. But I mean, if we also tried, if you use this on ChatGPT, doesn't work. Yeah, but we did some further tricks on ChatGPT itself. Not only us, but many other teams from the whole world also did some research to see how to make ChatGPT to see toxic words. I think there are many ways. For example, jailbreaking. For example, prompt injection. So this kind of thing. So indeed, so this is one of the major concerns if you want to deploy ChatGPT to large scale. Yeah, which seems to be the case in a few months. So next thing is memes. So again, so disturbing. I mean, not this, but next one. Yeah. So memes is the younger generation, the way of communication. So memes can be many things. Yeah, for different countries, no matter what your culture, whatever internet you are service you are using differently, you share one thing that is we like to use memes. Yeah. Unfortunately, memes also be liked by people who are toxic online. Have you guys heard about a website called 4chan? You better not. You know, 4chan is a website that is purely anonymous, but all the let's say bad people in society. I want to say some even worse word. All the bad people in many of the bad people in society just publish all kinds of racism or whatever, and then attack things on 4chan because it's purely anonymous. Yeah. They generate I mean also those people also like to use memes, which means they are using memes for hateful content. Yeah. And then actually we are also studying whether we can use, I mean, another one of these memes is on 4chan, or this kind of memes on 4chan. One of the things is like they like to have different variants, so different versions. So in this work, it's not about machine learning itself, but we are using machine learning as a tool to see whether we can catch evolution of hateful memes spreading on 4chan. Yeah. So Oakland 3. So what do we do with following? So we train a model called CLIP, which is a contrast learning model. Yeah, so nowadays, 2 years ago, you can consider this as a state-of-the-art big model, but now it's like a very basic building blocks. Yeah. So basically, we are using some. We collect data from 4chan. The 4chan data you have images as well as text. Images, text, we pair it to fine-tune a pre-trained CLIP from OpenAI. Once we train this, we discover that our trained meme-generated, I mean, meme-oriented CLIP be able to tell us many different things. Can help us to track many different memes. Because from 4chan, you can collect all kinds of images, many images. But from this, how do you automatically track whether there's a trend on a certain thing? For example, Pippi the Frog is one of the most hateful memes on the internet. Yeah, I met the original comic designer. I mean, the commission or something, I guess. I met this person who created this in San Francisco in 2018. He's a normal person, but he just dropped this comic and for some reason was hijacked by the 4chan people. Now become hateful thing. Yeah. Anyway, so once you fine-tune this CLIP, turns out Pippi the Frog, and then you add whatever these hateful notions, you add it together, you can see whether the dataset contains, let's say, a different version of this. You could also, let's say, this is another very hateful symbol called Rappe-Niemirska. Yeah, this is very anti-Semitism. Yeah? And then turns out that you see, if you have a Trump, which is a notion, or you can call it the influencer, this is a known meme. You see, combine this together. Combine together means adding their CLIP embedding together. CLIP image embedding together. And then to see whether on my 4chan database, I have an image look like this. Okay, this is not automatic generation. This is searching. This is an image retrieval. Yeah, this is not generation. Okay, turns out the CLIP actually can help us to track many trends. So why we are doing this on the 4chan? Because I mean, since a few years, so many of the international large political events or whatever things, many things are somehow indirectly connected with the 4chan people's movement. Actually, yeah. So basically, this can be a useful tool to track it. Actually, yeah. Another thing is more new. So again, memes. But this time it's about stable diffusion, not clip anymore. This time we are seeing whether stable diffusion can generate hateful memes. So this is a paper will be published at the end of this year. So basically, we found, first of all, we take some text from 4chan that looked like a normal text prompt. Yeah, we did some structure analysis to filter all the useless sentences. We get some 4chan sentences that look like a normal text description for image. We throw to the distribution, we found that stable diffusion indeed can generate many, many hateful memes, even clustering them to 5 different clusters. Yeah. Second, actually, stable diffusion or this kind of text-to-image model also has the ability to modify existing image for certain style. Yeah, it can be let's say an automatic workshop. I mean, Photoshop or something. It turns out that this method can also easily to let you to modify, let's say, happy merchant to different styles. Which means stable diffusion itself can also be used or misused by the people on 4chan as well. Yeah. And this is another thing, but this is more linked to this machine learning model itself. So in the future, I hope that the stable diffusion will build some safeguard. I mean, build some other extra layers to make sure my model cannot be used for this purpose, which will be difficult. So if you do this kind of research, this is a area that in at least security not many people have touched. Yeah, have touched. But however, you do this research, relatively easier to get your paper be more visible. Yeah. On the other hand, you also take a consequence. For example, this is the original 4chan post. Yeah, and this person is me. So back in 2020, this is not this is a paper in the beginning of 2020. At that time, the COVID starts, and unfortunately, there are many xenophobic behaviors or words of this. So we just did the data. I mean, collect the data from 4chan to see the trend of xenophobic behavior there. Yeah, we put the paper on archival in April, I guess. Yeah, and then in June, in July, I guess. So all the authors' images are on 4chan already. And then these 4chan users are so nice, they even give me fashion advices. It makes sense. I mean, that time my glasses indeed small, so I changed it. But so you see, this is fully anonymous. This is fully anonymous. I mean, this is already deleted because that time, I mean, we have other colleagues like people track these things. Can I put it on Twitter? Yes. But you think differently. So you think differently. So these are the 4chan users who read the paper from archive. Once he read the paper from archive, he is able to find all the author website and take our photos out. Is this a normal person on the street? I mean, you ask people outside, so are you reading archive? I think you are crazy. So which means, 4chan users, they are fully anonymous, but they might not be that far away from us. You think about it, how many people know archive? Yeah, it's kind of scary, but anyway, so I mean, I only did a few work on this. I mean, I'm not only told he did a lot of work on this, and I think I'm not on the full photo on 4chan is quite popular. They even have specific memes for him. So I guess if you work on these topics, be prepared for this. Yeah. And what else I have? All right. So we also in my lab we also did some other safety works. This is more close because my lab for past 8 months we been for some this kind of topics. So all these papers are more or less 2023. We also did this MGT bench, which is benchmarking all the existing methods to detect whether text is generated by ChatGPT or not. Also, if you are, you are grading, bachelor students' reports, you can use this tool to see whether they are using ChatGPT wrote it or not. Yeah, and it's only a benchmark. So, I mean, besides that, so if you guys are younger students, we also open source some of the code we are using in the lab. For example, I'm a doctor or I'm a hospital, which include the state of art, many of the membership inference or backdoor or model statement attacks codes here. So if you are new to this field, you can do that. Also, MGT bench, you can directly use it to check whether text is generated by ChatGPT or not. Again, we only integrate all the existing methods by others to check. Yeah, but this method obviously is not perfect. Yeah, but while we just provide a platform, a benchmark. Yes, this is the slides I sent all my collaborators, but before that, so I have one more thing to say. This is the last thing I want to say. So this thing, you can, this page is only my own opinion, so do not take it very seriously. Yeah, whatever I say, this is my only opinion. You can take it for reference. So,
I just get that. Did you try?
So,
speaking of privacy,
yeah. 3 years ago, when I started working on GNN and privacy or string links, the one I talked about, that time I saw that GNN is really an advanced model. So machine learning will in the future. Everyone's using GNN in the future. And then 2 years ago, I started working on SimClear, so contrastive learning, you got heard about it, self-supervised learning, so SimClear. Also 1 year and a half ago, you have this mask autoencoder. It's another self-supervised learning idea, which self-supervised learning you can check online anyway. So, but those are the way of a more advanced way of pre-trained model. I feel like, okay, every time that people predict that there will be the future of machine learning, everyone will do this. Everyone from future will do self-supervised learning first, and will do the supervision task. And then suddenly last year, everything is about text to image. Yeah, so in the beginning of the year till the end, I ran talk about text image. And then end of last year, suddenly there's a thing called ChatGPT. Yeah, people suddenly realize, oh my God, my machine learning model can do so many things I don't even know. Okay? And the model indeed getting larger and larger, newer and newer. And, because 3 years ago, I really thought I can work on GNN for a couple of years. Turns out I only work on GNN for 6 months. Yeah, self-supervised learning, 4 months, I guess. Text to image, 6 months. And now all my team is on large language model, ChatGPT, etc. The model, it becomes so big. This so-called large model, ChatGPT or GPT-4, they are not large in the sense like from less than 50 to less than 100. It's like a significant different magnitude of the size, which means you have even specific way of using these models. Previously, before ChatGPT, how you use a model? You get a model, you fine-tune with your own data set for a specific task. Yeah. For ChatGPT, I think all our institutes GPU combined together, we cannot even fine-tune ChatGPT, not even train from scratch. There's only a few places in the world, mostly companies, are able to train such large models from scratch. Yeah. So which means there is a new things of using these large models like in-context learning, prompt learning, or prompt engineering. You guys haven't heard about these notions, this probably is the only useful line in this slide. Yeah? You can learn this a bit. This is probably the future of machine learning. Like in the future, I can imagine a world, what's this? Random thing. So it might be in the future in the machine learning. Right now, you are using Python, you're using PyTorch. In the future, you can say we are using text editor. A bunch of people sit together, come up with different languages, and say, try it on ChatGPT, see whether it gives you a good result. And the good prompt is your contribution to machine learning. Yeah? But when the model going to this scale, many of the attacks I have done are meaningless now. For example, membership inference. First of all, practically, so if your model like ChatGPT, this scale, membership inference, the signal is 0. Impossible to get it. Even I find a very good algorithm to do membership inference. I guess this sentence is indeed a member. OpenAI will never tell me this is a member. I have no way to verify it 100%. Yeah, because this large language model, everything is centralized. So large model, everything controlled by them. So it will not tell you, well, this is my member, this is not my member. Yeah. Another thing, poisoning attack, backdoor attack. No matter what you do, poisoning or backdoor, eventually you need a part that is so-called fine-tuned model. Yeah, you need a fine-tuned model. You have to fine-tune even a few epochs, you can poison the model. Again, we do not have GPU. Yeah? Don't tell me that LoRa is the way to fine-tune the model, because LoRa fine-tuned, but you take LoRa out, the model itself didn't change. Yeah? So that's not really a backdoor, actually. Yeah? And even you are able to someday, we are able to use our own GPU to fine-tune, let's say Llama or ChatGPT, Llama, or etc. You will be able to do that. What is your threat model? You write a story in your threat model saying that one employee of OpenAI suddenly become bad and then poison the data and then pass all the things. So this is not like the old case because these companies, they collect data, they are using, I believe they follow a very rigorous way to clean or collect the data. It's not like your poison data is so easy to be collected by that. So which means that you need to have some inside rats to match with you to the poison model. So basically you are writing more stories here as well. Yeah. Again, GPU is the issue. So my own understanding or my own opinion regarding trustworthy machine learning for attacks, probably the next few years or few months or few weeks, we will mainly focus on the safety related issues. By safety, what I mean, let's see, how I can make the model to say something bad, generally something bad. Or another thing, so one of my colleagues told me the other day, so which also triggered me a little bit. He said that as human beings, we met in the last golden few months where everything we saw on the internet is written by humans. In a couple of months, he said that maybe everything we saw, most things we saw are written by machine. Yeah? I mean, believe me or not, I suppose many of you guys might use ChatGPT to write some part of your paper. Might, at least my students sometimes wrote it. I realize the writing style is different than before. Yeah. So imagine this model, we do not understand its capability. We do not understand what kind of bad things it can do. And everything we see is written by it. It's generated by it. The damage to society is sometimes unbelievable, actually. So you cannot imagine it. So, I mean, if you want to work on trustworthy AI in the big model era, so in my opinion, do not work on membership inference or whatever, backdoor, etc. Just try to see whether these models will, have some bad behaviors. Because if you someday, let's say, if you find a pattern with this pattern inside, ChatGPT will for sure say something bad or for sure say something wrong or fake news. This will be a very big influence. Will also help the human society, society very much. Yeah. Anyway, so this is, again, so this last slide, the only thing you probably should focus on is in-context learning or prompt learning. Try to learn this idea. So you don't do Python, you can still use this to use large language models. No problem. All the other things is just my own opinion. So just take a reference, but don't think it too deep. Okay, guys, that's it. Okay, thanks.